what time is the ball 50 meters above the release point? Only two numbers are given in the problem. I do guess I do need to specify one other thing. Ball is thrown into the air near the surface of Earth. In most textbook problems, that assumption, that is assumed. All right, so let's write down, I got delta x, di, df, a, and t. All right, what do we know?
Is 15 meters the displacement?
You said 50? Tatum just established something for the entire problem. What did she establish?
Where it ends. It's
No, that was given in the problem. There were basically two things, there were two different numbers that we could have used for displacement. She picked one of them. What did she do? Or what's the other value that I could have used?
30 meters.
No, not 30.
20?
No.
Oh, okay, I'm just guessing. It was just, he just didn't write it, so we just fixed it.
All right, we'll keep going. What else do we know?
Oh, wait, is it possibly like the, well, no, I was gonna say because it's positive, it would be the direction of it.
Okay, keep going with that, step louder.
Louder, okay, so because she said it was 50 meters and that's positive, the up would be above the ground and therefore up is positive? Like,
So close to perfect. It's the way you said it, at least the way I heard it, made it sound like because it's above the ground, it's positive.
well, because she decided that 50 meters is positive. Like she could have said that. I don't know how to say.
Okay. You want to figure it out, or do you want me to cut you off?
You can cut me off.
All right, almost exactly it. When she said 50 meters, she established up as positive.
Yeah.
That's the convention. That's what you were getting really darn close to saying. She could have said negative 50 meters, in which case up would be negative, down would be positive. So once that first number is written down, it's now been established, up is positive. All right. So now, what's the other piece of information?
Initial velocity
Is,
30 meters per second.
and it has to be positive because we established that's positive there. So this is 30 meters per second. And there's one other piece of information that's not written down, but you're just supposed to know.
Time?
No, not time.
You're looking for
The acceleration's constant. The acceleration's constant. No.
Wait, what was the question?
All right,
Oh.
let's just stop right there. Drop the last word and say it again.
The acceleration.
Yes. For objects that are near the surface of the Earth, we're ignoring air resistance. What is the acceleration of the objects?
Gravity. The
So,
weight.
I'm looking for a number.
Isn't it the weight of gravity? Okay, what he said?
Yeah, 9.8 meters per second, and since it's pushing down, it'd be negative.
Okay. One more time, what are the units?
9.8 meters per second. Negative 9.8 meters.
Meters per second. Square.
Squared. And it's negative because Tatum said so, so down is negative. So negative 9.8 meters per second squared. It is not constant. It is not. Let me emphasize that. It is not a constant. In case you missed it, it's not constant. It is not a constant. In Winston-Salem, 9.798 meters per second squared. How do we know? Because they have actually mapped pretty much the entire world. But we are more fortunate. We know better than almost any other place in any other college or university or school in the country. Because when they were doing these experiments to try to figure it out, they've redone it since then, but when they were first doing it, the device used to measure the acceleration due to gravity here was done right out there. You got Miller Street and Silas Creek, and then as you move this way, there's a road that tees into Silas Creek. Where that road tees, if you go to the median, that's where the device was. We have the device right there, and there's not many places in the world that can be that specific. So, generically, 9.8 is the meters per second squared, is the acceleration due to gravity. In this case, we're dealing with the vector. Down is negative. We are given this. And if I'm trying to figure out the time, what equation would I use? The last one doesn't have time in it.
Wait, what was the question?
The question is, what is the time? The ball is 50 meters above the release point. And so the question, so what I'm wondering is, which of those equations would I use to find time?
The third one.
All right, if I use the third one, I get 50 is equal to 30t plus 1/2 negative 9.8 t squared. What kind of equation is this?
That's the quadratic equation.
It is. And how do you solve quadratic equations?
The quadratic formula.
I would recommend it. I did tutor a student a number of years ago who, every time he was given one of these problems, did not use the quadratic formula. He completed the square every single time. In essence, he derived the quadratic formula each time he did the problem. Okay, it worked for him. So to use the quadratic formula, we need to set it equal to 0. Personally, and this again is just me, I like the coefficient of the quadratic term to be positive, so I'm going to move everything over to the left. So I get 4.9 t squared minus 30t plus 50 is equal to 0. T, don't say you blank on the quadratic formula and you don't want to have that tune running through your head like it is me right now.
Do you remember it? I can tell you.
So you would then go to the first page of a test or at the top of the quiz and it's there, or if I didn't give it to you, ask, I'll put it up on the board. So 30 plus or minus the square root of 30 squared minus 4 times 4.9 times 50 divided by 2 times 4.9. All right, so if I say what is the discriminant, what am I asking?
The part of the inside the square root.
Okay? And Eva, you're about to say something?
Yeah, I was gonna say the same thing.
Okay. So what is the discriminant?
Are you asking us to solve it or tell you as it is right now?
I want to know what the number is to actually solve the discriminant.
Okay.
Negative 80?
What'd you get?
I got negative 80.
Negative 80?
Mm-hmm.
Anyone else got the same thing?
Yeah.
All right, so what does that mean?
Doesn't right? Imagine it's numbers.
It means one of two things.
Okay, it means that there's no square root to the problem unless you have imaginary numbers.
Therefore,
Therefore, your answer
that's what I was asking.
Wait.
What is a negative? We have a negative under the radical. It means one of two things. Let me spoil part of it. One of the things it could mean is that we've made a mistake somewhere. If we haven't made a mistake, then the other interpretation has to come in. What is the other interpretation?
It doesn't exist. Your answer doesn't exist. It's not real.
So the question is, if I throw a ball 30 meters per second, initially at 30 meters per second upwards, I would be impressed with myself because I could never throw it horizontally at that speed. If I can throw it up initially at 30 meters per second, is it possible that it never reaches 50 meters? If it is possible that it never reaches 50 meters, then the negative solution, the negative under the radical could mean it can't happen. It's not, there's no answer. So just sort of think through it and think, all right, does it make sense that it's possible? So for example, if I'm doing a ball thrown off a cliff and I want to figure out how far from the bottom of the cliff it lands, if I get a negative under the radical in that situation, there's a good chance that I know if I throw a ball off a cliff, it will hit down below. So if I get a negative under the radicals, there's quite possibly I got a negative in the wrong place, and what I've actually solved is a ball that's going that way. Would be a heck of a spin. Anyway, we are done. Lab is I got a thumbs up there. All right. I assume you were not saying that.
Pardon?